Hello, welcome to Laura's Classroom. And so I am going to be sharing how to solve this problem. And so what we have is we have a firecracker and a coconut, and it blows the coconut apart. And so when we go read what is happening here, we see that it's going to blow apart into three pieces. Two of them are going, and they're equal mass. Two of them have equal mass. One is going to fly south and one is going to fly west. They are perpendicular to each other at 16 meters per second. So if we make ourselves a picture, pictures are always great in physics. This thing is going to blow apart. We're going to have something going south. We can go ahead and say because it's heading south, its velocity is negative 16 meters per second. It's got some mass. We don't know what the mass is. It doesn't tell us, but let's, we'll come back to that in a minute. And then it's got a piece going west. And so we can say its velocity going west is negative 16. Because remember, if we use like our coordinate system here, north would be positive, east would be positive. Okay. West and south would be negative. And so we do not know what this one's mass is. The third piece has twice the mass of the other two. Okay, so we're going to have probably something flying off at a trajectory, something like this. We do not know its velocity, but we do know its mass is going to be 2 times the other two. So we've got to find the velocity, and we need to know the direction. So we need to know this theta here. So the first thing that you've got to realize is that the momentum of the system before was 0. Okay, it was 0 kilograms times meters per second. It was 0 because it was at rest. It blew apart. So if we go and break all this up into its component pieces, we've got to make sure that everything is adding up to 0. So we've got a component to this vector here that's going east, and we've got a component that is going north. Okay, so what we're going to do is we're going to simply reconcile what it's doing in the east-west direction, and then we're going to reconcile what it's doing in the north-south direction, and then we're going to apply it to figure out what it is going at the diagonal. Okay, so if I'm just going to make up a mass, by the way, because it didn't tell us the mass, so I'm going to make one up. I'm just going to call this one 1 kilogram. I'm going to call this one 1 kilogram, and I'm going to call this 2 kilograms, because why not? It's okay. It didn't tell us what it is. The numbers will work out okay as long as we just put in one that's 2 times the other. Okay, so we are going to have, it's going to add up to 0. This is my momentum before. My momentum after, my equation for momentum is mass times velocity. So I'm going to do my mass of this guy here. It's 1 kilogram, and it's moving at negative 16 meters per second. Well, it's going to be over here. We got this 2 kilogram one that's doing who knows what velocity. So we can do 2 kilograms times who knows what. Okay. So when we do some math, this gives us negative 16 kilograms times meters per second plus 2 in, kilograms times the final velocity. And we've got to rearrange our equation. So we're going to add 16 to both sides. So this is going to give us 16 times kilograms times meters per second equals 2 kilograms times VF. Okay. We can divide this by 2. This cancels. Divide this by 2. And so this will become 8. And what you'll see is that your kilograms and kilograms will cancel. So you'll be left over with meters per second. So my final velocity going in this direction is actually 8 meters per second. It's positive because it's going east. Likewise, because this is the same exact problem, we can say my final velocity of this other one is also 8 meters per second, and it's going north. Let me go ahead and see if I can clean up some of this a little bit because we've got a lot of gibberish going on. So we'll take away some of this math work here, and let's do a little bit of, something maybe you learned in 8th grade math. Okay. So if our two vectors here are adding up to, we got 8 meters per second going this way, 8 meters per second going this way, we can find out what this resultant vector is by using the Pythagorean theorem. So we can simply do 8 squared plus 8 squared. I mean, we're doing a squared plus b squared equals c squared, right? Equals c squared. Okay. And so when we do a little bit of math, we are going to get, let's see, we're going to get 11.32 meters per second. Okay. So that's going to give us the speed here. This is going to be 11. And we should probably do only 2 sig figs because this gave us 2 sig figs here. So 11 meters per second. And then it's moving, these two sides are equal. So we know that this is a 45-degree angle. So it's 45 north of east. I hope that helps. Thanks.